Hello friends, welcome to VK Lectures. In this video, we will be discussing the question number 40 from the Karnataka Set 2024 question paper. Photodiode function as. Here are 4 examples. Let us see what is a photodiode. Is a semiconductor device that convert light energy into electrical energy. Similarly, it's a semiconductor means it's a PN junction diode which is sensitive to light. It works on the principle of photoelectric effect where incident photons create electron hole pairs. It is usually works under reverse bias called photoconductive mode. The mode is photoconductive mode. This is usually done for fast response. Now it can also operate without bias in the case of photovoltaic mode. Examples are solar cell. The output depends on output of the photodiode. Either it can be current or voltage. Depends on the amount of light. Higher the light, more will be the current or voltage. So a photodiode works in two modes. One is photoconductive mode and another one is photovoltaic mode. In photoconductive mode, it is reverse bias, and in photovoltaic mode, there is no need of biasing. The parameters are it is fast, sensitive, and used in communication systems. It is also used for sensors or detectors. In photovoltaic mode, it is usually used as solar cell. It produces voltage and less noise. Now here is a difference between photoconductive mode and photovoltaic mode. Biasing condition for photoconductive mode is reverse bias, and in photovoltaic mode it is without bias. There is no external voltage. In the case of the output signal, it generates current as the output signal proportional to the intensity of light. While in photovoltaic mode, it generates voltage. Example is the solar cell. And the response, since there is reverse bias, the response is faster. And since there is no bias, it is slower response. Noise level is higher because again due to the fast response and reverse bias, and in the case of photovoltaic mode it is lower, no reverse bias or leakage current. Sensitivity, it is more sensitive and suited for low light levels. Even for lower light levels you will get the signals, and it is less sensitive compared to photoconductive materials. Applications are optical communication, fast detectors in the case of photoconductive mode, and solar cell and low noise detectors in the case of photovoltaic mode. Now according to the option, the photodiode is something that works as a photoconductive device while working with reverse voltage. This is also partially correct, that is photovoltaic device while working without a reverse bias or no bias. But this is usually used for photoconductive device as reverse bias voltage with reverse bias voltage. So option 1 is correct.